guess when it comes to those types of questions, the first thing you got to do is like read the problem. You got to understand what's being asked of you. Got to read it, got to understand it. If you don't get that from the jump, you're already going down the wrong path. So let's talk about that first. All right, so a rectangular corral, two adjacent sides, right? So basically we're talking about something that looks like this. We split right down the middle. Yeah, just like I said yesterday, a lot of times you get the question, how does this help me in my life? Once again, I never have an answer for that, but I could just give you an example of how it can be used in the real world. That's all I can give you. So this problem in particular, it said something on real key at the beginning. He said you only had 200 yards of fencing. Like, if you're a farmer or whatever, like my line brother has a farm, if he's buying fences, he only has so much money to buy a certain amount of fencing. So he's limited. So we're going to have to optimize the area based on the amount of fencing you can buy, you can afford or whatever. So you can only work with 200 yards of fencing. I need to get the most out of that. So I got to optimize it. Yeah, so basically I got it drawn out here. And as you can see, anything that I have flat like this, I use X. Anything that's vertical, I use Y. So if we count that all the way around, you got 1, 2, 3, 4 of those of the X's, 1, 2, 3 of the Y's. Yeah, so perimeter is when you add up all your sides. You add up all the fencing by getting the perimeter of it, right? Make sense? And there it is. My perimeter is equal to 4X's plus 3Y's. So that's pretty simple if you think about it. But they also told us that you had 200 yards of fencing. So my 200 is still equal to my perimeter. And since I'm dealing with area, which would be 2x times that times y, that's why I have my area is base times height, 2x times y. So I still got to come into this formula and get this variable by itself, subtract 4 to get that over here, and then once that's gone, I can divide by 3. That's why I divided by 3. Now y is equal to all of this. That goes. So all the optimization happens not here. This is just the area formula. 2x times y, but remember y is equal to all of this. So I just threw that all together so I can keep one variable instead of x and y. Now all I have is x's. So remember what I said, optimization doesn't happen on area. It happens when you take the derivative of the area. You optimize the area by taking the derivative of the area. There's my derivative. So now that I solved that part, I got my derivative, I set that equal to 0 to solve for x. Once I solve for x, x is 25. That's 25, that's 25. So once I put the 25 here, that's basically going to be 200 minus 100 over 3. So my y value is equal to 100 over 3. That's how tall we are right here. There you go. See the fence? Still cut down the middle. You see the areas changing, the numbers are jumping. And then look at there. And look at that. So once I hit 25, you'll see right here. Look at the area. As soon as I move it, see how it got smaller? See, that's the highest it gets to. It don't get no higher than that number right there. That's the highest it gets. Okay, I got a controversial example for this optimization. I was watching Narcos, Mexico season. And there was a part where this dude decided he was going to go from one part of the drug trade to a whole nother product, right? When he graduated to that new product, he knew that he can maximize his profits because his shipments can handle way more. And he can bring in more money using less space. Like these Apple computers, they're getting thinner and thinner. I remember like in one big box of shipments, say for instance 10 years ago, they can hold 5 computer boxes. Now they can do twice the amount in the same packaging. You get what I'm saying? Maximum.